Good morning. I am audible? Good. I will turn my video on. Yes. Am I visible? The video? Shivam, Apurva, Amit, Devashish, Omkar, Gaurav, Suraj, Nachiket, Akash, Sandesh. So many are yet to join. In the last lecture, we were discussing about the trends in the energy consumption. So those were observed essentially at the global level, and we have seen that the major uh, major share is there for the conventional fuels, that is the oil, gas, and the coal. And very small contribution was as such there from the renewable energy sources and the nuclear fuel as well, isn't it? That is what the summary in one line that we can give for the discussion that we had in the last lecture. Now, as far as the today's lecture is concerned, so our discussion would be there for this energy trends or the energy scenarios at the national level and as well as at the state level, and what different installed capacities are there, what proposed extensions are there, proposed extension in the installation capacity, generation capacity, specifically at the state level. So these are the two major points as far as the today's lecture is concerned. And I'm sure that by the end of today's lecture, we can definitely say that the first half part of unit number one that we can finish, it is over, that we can say. So the introduction to the subject of the power plant and the energy scenario. So that is nothing but the contents for the first part of unit number one. And as we know that the second part, which essentially deals with the what you can say, the economics of the power generation. So we'll see the different factors for that one, which are essentially used for the calculation of the electrical energy. So that is the second part. Maybe from the tomorrow's lecture we can start with the second part, and it will definitely involve some calculations, some numericals, some equations will be used in the second part as well. In the first part, that is purely the theoretical one. Now, the questions those are say supposed to be asked for the first part of unit number one. They are very generalized. So rather than say writing a very specific or the pinpointed answer, so they are nothing but of the descriptive nature. So as you are having the good habit of say the reading of some good reports which are related for the energy, some good literature which will give the insight for the consumption or the trends in the energies, their patterns, then you can frame, you can write down the answer in your own words. Their comparison can be made in your with respect to your own views, I will say, and not necessarily that hard and fast. This has to be the only answer. So that is what the freedom is there in writing the answer for the first part of unit number one, isn't it? But when we touch upon to the numerical part, problematic part, so definitely you are bound to use a certain set of the equations only, and make the necessary substitutions and find out the different unknowns for that particular numerical. So that is a framed one, it is a structured one. So you don't have any as such a lot of freedom or the flexibility in that. very few students as such joined, only 17 I can see here. Okay, out of the 55, 56 which are there for the power plant engineering, including me. So as such 18 are there. So let us wait for a minute or two, then I can start the discussion for the today's lecture. Is it okay that the pace with which we are moving, or the speed that with which we are discussing in the lecture, with the same speed that we should continue, or should I reduce, or should I accelerate the delivery of the contents in the lecture? Please write down there in the comment box so that I will be convinced with your views as well. I will share the screen, and during the entire discussion, that if you find any point as such to be suitable, even though I do not dictate that one, because it is more of a discussion rather than writing pages or the paragraphs, isn't it? So discussion is more important rather than dictating and writing the paragraphs. But if you think any fact that is of the significant importance, so you can write down at your end in your notebook, isn't it? Because as such, when I start with the PowerPoint presentation, so I don't know what that is there on the other side of the screen. I hope that you are quite attentive enough on the other side of the screen during the entire session, isn't it? So let me share my screen, and to begin with the discussion in the today's lecture. We'll quickly recap the things that we discussed in the last lecture, and then from that point we can take our discussion further. So this is what we started in the last lecture. The worldwide power scenario, or the trend of the energy consumption over the last 50 years, 1965 to around 2015. So quite a sufficient span is taken into consideration, and that shows the trends in the consumption of the various energy resources which are available, oil, coal, and gas. So it was seen that the topmost curve, which is applicable for the oil. So oil forms to be the largest consumed energy source to satisfy our requirements, to satisfy our needs. And slightly there is a drop from say 1980 to the 1985, and from 1985 onwards, more or less, it follows the linear pattern. For the whole, it was almost a linear one up to the say 2000, and from 2000 to 2005, 2010, slight increase. There is a black colored curve which can be seen here, and then small ups and downs can be seen there in the consumption pattern for the coal. Then for the gas, which is shown there in the purple color, third curve which is from the top in this arrangement. So the pattern for the gas, that was seen almost linear over the 50 years. So not much variation changes can be seen in the consumption pattern. And as far as the nuclear and renewable energy sources are concerned, their patterns are concerned, very slow and steady rise, we will say. Very slow rise, or almost from 1965 to the 1980, it is almost stagnant. It follows the flat curve, or it is nothing but a straight line, a flat straight line rather than inclined one, isn't it? So almost this red color and this green color line, one for the nuclear, another for the renewable, that almost followed the same pattern. And then it can be seen that from the 2005 onwards, so the difference between these two have increased. So difference between nuclear and the renewable increase, and definitely we can see that the trend of this green curve, which is there from the renewable, so that to move toward the upward direction, move toward the sky, isn't it? So that is more beneficial for us. That is what the discussion we had for this slide. Then the pie chart was being shown, the current contributions from the various sources used for only the power generation, isn't it? And their stated policies, or we can say the future plans by the end of 2040 to reduce the consumption of these fossil fuels, that is nothing but coal, from 38 to 25%. And to meet the sustainable development, it is further expected to reach to the bottom value as close to 4%. The green portion that we have seen, so 16 plus 2, 18 plus 5, 23 plus 3, that is 26. So around one fourth of the contribution is there from the green color. So what that green color stands for? Hydro, solar, plus wind, plus other renewables, isn't it? And it is expected that by the end of 2040, this green portion have increased 15, and this 11, 26 plus 13, 39, and plus 4, 44, isn't it? So from 25 to 44, so slightly smaller than the double, isn't it? So generation pattern is going to change. But to meet with the sustainable development, it is seen that major portion or major potential thrust is there on the this renewable ones. 18, 19, that is nothing but the 37, this 58, and now 966. So 66% of the energy requirements for the power generation, so those will be satisfied, or those are supposed to be satisfied with the help of the renewable energy sources only, hydro, solar, plus wind, plus other renewables. Okay, so two-third energy consumption would be satisfied with this, and very less importance is there for the coal, 4%, and meager amount is there only for the oil, that is 0.4%. I also stated toward the end that look at this 5%, which is nothing but the CCUS. Okay, so it is absent there in the stated policy, it is absent there in the pie chart which is shown for the current position or the current situation. It is no more there, isn't it? So it is definitely seen here 5%. If you look upon the information for this 5% CCUS, another diagrammatic representation for the different sources, latest one 2019 trends, 2019 patterns, the contributions for the coal, gas, hydro, nuclear, and other renewable and non-renewable. Okay, that we discussed in the last session. And the per capita energy consumption for the different countries or the different regions in the world globe that we have discussed, Asian countries, then European, the American, and the East Asian as well. East Asian, that is nothing but what you can say, it is the Japan, okay, East Asian country. So that is 3,600, whereas as far as India, it is 600 only. So Japan consumes as much as 6 times more energy as compared to that of India. United States being the highest one, that is 7,032. So more than 11 times than that what the consumption of for the India is there. And as far as the China is concerned, in the Asian country, so it is 2,000, India being the 600. So it is more than 3 times the energy consumption is there per capita for the China as compared to that of India. The global energy trends for the units in the last 20 years. So we have divided these particular trends in the two different distinct zones from 1998 to the 2007, that is the first 10 years, and then from 2007 to 2016, next 10 years. So from 44.4 in 1998 to 107, so slightly less than 3 times the requirements have increased or the consumption trend have increased. But for the immediate last 10 years, 2007 to 2016, it shoot up from 107 to 419. So it is nothing but the 4 times it has shoot up. So the speed or the pace with which the consumption is increasing, so that is higher in the last 10 years as compared to the preceding 10 years, we will say, isn't it? So that was the point where we stopped our discussion in the last lecture. Let us begin with the current status for the power generation in India. I will just make up the entire slide, and then we can have the discussion on this parameter. Some of the numbers are the recent one, but some of the numbers may be slightly 5 or 6 years down the lines, before the 5 to 6 years before the current status. Okay. The electricity sector in India has an installed capacity of 372 gigawatt, isn't it? Very high capacity, 372 gigawatt. It's the latest figure, that is at the end of July 2020. So this installed capacity of the 322 gigawatt, that includes the capacity not only from the renewable energy sources but from the non-renewable energy sources as well. Coal, oil, gas, the non-renewable one, and the renewable, the hydro, the wind, the solar, uh, and so many which can constitute the part of the non-renewable one. If we see the recent past, 5 or 6 years ago, India became the world's third largest producer of the electricity in the year 2013, with 4.8% global share in the electricity generation, surpassing Japan and Russia. Now we say that India is nothing but the sixth largest, what you say, second largest populous country in the world, isn't it? So every sixth person in the world is nothing but India, isn't it? Total globe population, which is considered to be 650 billion. So it is nothing but 135 billion is there for the India. So every sixth person in the world is nothing but an Indian, and we constitute around 16 to 17% of the world population. And you see the global share that we have in the electricity generation, so it is less than 5%, isn't it? So it is less than 5%. The renewable plants that constitute around 28.43, so nearly 29% of the installed capacity, and non-renewable, that is around 72%, isn't it? So one third is there, nearly slightly less than one third is there for the renewable, and slightly less than three-fourths is there for the non-renewable plants. The capacity, India generates or generated 967 terawatt hours of the electricity in the year 2013. So that's why I said some of the figures, some of the numbers may be slightly 5 or 6 years ago, which may be say updated in the coming slides as well. So 967 terawatt hours, 967 150 gigawatt hours. It is such a huge energy consumption that we have, but still there is scope. We are facing the scarcity of the energy as well. So there is still a scope for increasing the installation capacity and increasing the electricity units to be produced. The annual generation of the electricity from all types of the sources, 1102.9 terawatt hours in 2014. So it means that within the gap of 1 year, that is from 2013 to the 2014, 2013 it was 967 terawatt hours, and the 2014 it is 1100.2 terawatt hours. So there is a slight increase of around 130 140 terawatt hours in a small gap of, or a small duration of the 1 year, isn't it? So these are just the numbers to understand that where we actually stand there. Uh, in the first line there, we forgot to mention that India generated around 1,330 billion units for the period of July 2020. So very recent or the very latest figure that we have as far as the installed capacity of the different power plant is concerned, and the number of units that were generated by the end of July 2020. As of March 2020, the per capita total electricity consumption in India was around 970 kilowatt hours. And in the earlier slides, just I will go back to that. This one, energy per capita usage. So here, slightly older figures are there. That is 640 kilowatt hours of the energy used per capita. Okay, 640. And now the current number, 970, isn't it? So between nothing but from 600 to the 900 that we have increased. The per capita annual domestic electricity consumption in 2019, the domestic consumption I am saying, 120 kilowatt hours in rural areas and 400 kilowatt hours in urban areas. So definitely this trend is not an we can say a surprise to us, as we are there in the urban areas or the metropolitan. So definitely different types of the electrical appliances devices are being used to the large extent. So we can see that this trend is nothing but as per the expectations as compared to the rural area, isn't it? The electricity energy consumption in agriculture being highest 18% in India, because India being the say the agriculture based economy, so definitely larger energy consumption can be observed, can be seen there in the same sector, that is agriculture. So around 18%. So one fifth is the energy consumption there for the agriculture sector. One more point, the per capita electricity consumption is lower compared to many countries despite the cheaper electricity tariff in India. Even though that way of saying that it have increased from 600 to the 917 kilowatt hour, but still it is far less as compared to the other European countries or other developed countries, because that was seen there in the last slide. This one, isn't it? The Brazil, China, they are again far ahead as compared to us. 1300, then 2029. So still we are lagging the Brazil itself. 1371 per capita. This is an older figure. If the current figure of the India is taken into consideration, so that is nearly equal to 920, isn't it? That is mentioned here, 917 kilowatt hours. Okay, so still there is a wider scope to increase this electricity energy consumption, and which will definitely help us to improve upon the standard of living. Uh, this is nothing but the information that has been said taken from the government of India website. It is nothing but from the Niti Aayog, which was earlier nothing but the Planning Commission. So which makes some targeted plans or the proposals for the increase in the installation capacities for the policies rather. And this particular chart is there for the electricity generation in kilowatt hours. Different sources are taken into consideration. Fossil fuel based electricity, that is nothing but the oil, gas, and coal. Then another red, in the red color, it is nothing but the hydro and nuclear. Then the somewhat there in lighter blue color, it is nothing but the renewable based energy. Okay, so that is it is nothing but the share which has been shown here. So on the y-axis, it is nothing but the energy generation in kilowatt hours, and on the x-axis, it is nothing but the time period or the duration which is shown from 2012 to 2017 and 22. So after a gap of every 5 years, it has been shown. Okay. On the right hand side of this chart, the percentage contribution or the percentage electricity generation made by that particular domain, whether it is a fossil fuel, whether it is a hydro and nuclear, and whether it is a renewable based electricity. So it is seen that uh, for fossil fuel 2012 2017, so there is an increase from say nearly equal to 800 to slightly larger than 1000, so it is 1200. From 2022, 2027, 2032, so it is continuous increase can be seen in the contribution which is made by the fossil fuel based electricity. Electricity which is generated by coal, oil, and the gas respectively, from 2012, 2012 to the 2032. So in this 20-year span, the contribution have or it is projected to increase from say nearly equal to 800 to somewhat nearly equal to the 1700. So more than double energy would be generated from the fossil fuel based electricity. And the trend which will be seen or which are projected after 2032. Okay. So this blue colored, okay, this dark blue colored, say the towers which can be seen here. So from 2032 to 2037, 2042, 2047. So next 15 years. So I don't see that there is any substantial increase from 2032 to 2042 in these 10 years. But definitely in the earlier 10 years from 2020 to 2032. So it is slightly less than 1500 to greater than somewhat nearer to 1700. But from 2032 to 2037, it's a very negligible rise, we can say. Similarly, for the next 5 years, 2037 to 2042, a negligible rise. And after that one, post 2042, till for the next 5 years up to 2047, so it is showing a downward trend. Okay, so the energy consumption trend from 2042, that is showing in a downward direction as far as the fossil fuel based generation of the electricity is concerned. So it is expected that the share to increase from 2012 to the 2032, then it will remain stagnant for the next 10 years from 2032 to 2042, and a decline pattern or the decrease pattern would be seen post 2042. Okay. Then as compared to the next one, that is nothing but hydro and nuclear. Hydro, that is considered the renewable one. 2012, 20, 27, 22, and 27 here, and 32. So it is seen that from 2017 to 2027, there is very small increase in the capacity that would be obtained or generated from the hydro and the nuclear. From 2032 and onwards, so there is again increasing trend would be seen. So slight increase would be seen after every 5 years as far as the hydro and the nuclear are concerned. 2012, slight addition in 2017, slight addition in 2022, 27, and likewise, isn't it? So it is nothing but the slow but steady increase in the contribution which will be obtained from hydro and nuclear. And substantial is there still based upon the fossil fuel based generated electricity. The third one is nothing but the renewable based energy. So that will be obtained from the solar, wind, ocean thermal, the, geothermal, biomass, and the biogas. So likewise, from the different renewable based sources, the electricity generation in kilowatt hours. So that is expected to be. Look at this trend; it is very interesting. 2012, very small contribution. 2017, 2022, 27, 32. So it is shown that it is increasing to a rapid pace, isn't it? And can be also observed that the contribution here for the renewable energy source is very less as compared to the fossil fuel. Here it is less. In the 2017, it was also lesser. Then this gap between these two, okay, the gap between the energy generated from the fossil fuel and the energy generated from the renewable based sources. So this gap is reducing, isn't it? So this gap here reduced. Whereas in the 2042, so almost they are reaching at the same level. The energy that is obtained from the fossil fuel based sources and the renewable based sources. So almost they are reaching at the same level. And then post 2047 onwards, yes, the renewable energy have surpassed as compared to that of the fossil fuel based generation of electricity. Isn't it? So 50%, nearly equal to 50% of the energy requirements that would be satisfied by the renewable sources of the energy. So that shows the trend. Okay, this thick line that shows the trend that we can have for the electricity generation. So we can make a one comment here. Okay, what comment that we can make? Number one, the fossil fuel based electricity that is going to increase, say the steadily up to the 2032, then it will remain almost constant up to 2042, and then from 2042 onward, the downward trend would be observed in the fossil fuel based electricity generation. Second comment, as far as the hydro and nuclear are concerned, small but steady increase and the contribution would be observed. Renewable base slowly increasing till the 2032, thus reducing the gap between the fossil fuel and the renewable sources, then almost reaching equal to the same thing, fossil fuel and renewable based energy sources in 2042. And after 2042, the contribution from the renewable based electricity generation will overtake the fossil fuel based energy generation. So that is what it is proposed from the plans of the government of India, or the policies which are framed by the government of India. It is a planning commission. Earlier it was known as, now it is known as a Niti Aayog. So you can find out these numbers on the government of India website as well. Okay, so this that will give you the latest trends or the latest information. So rather than going in a book which will give some say the earlier information, older information, to get the updated and the proposed one, so you are supposed to refer the website as well, okay, depending upon your interest. Sources of electricity in India by the installed capacity. Now we have seen the sources of the electricity as far as the global level was concerned. The contributions, the one pie chart that was shown for the 2018, then 2040, and sustainable requirements by the 2040. That pie chart was discussed in the earlier parts of the slide. So that was there at the, we can say the global level. Now we are having our discussion at the national level. So these are the contributions made by the different sources in the generation of electricity of the installed capacity. So trends are somewhat similar what those are seen at the global level. So major player is nothing but the coal. Okay, major contribution is still taken care by the coal, because it is say widely available, abundantly available in India as well, and it is having say the cheaper rates, isn't it? So that's why the coal is abundantly extensively used for the generation of an electricity. From the hydro sources, so 17%, nearly 1/5. Renewable energy sources, 12%, very small. Natural gas, 9% gas-based power plant. Nuclear, very small capacity as such as that we have for the nuclear plant. And oil being the costly. And okay, we definitely know that India is not that much richer as far as this oil reservoirs are concerned, the resources are concerned for this type of the fuel. Most of the oil that we import, isn't it? And most of that imported oil is specifically used for the transportation purposes. Transportation, and we cannot afford to generate the electricity from the oil which is imported and which is very costly. So that's why it is seen that very small or negligible contribution is there for the oil as far as the Indian requirements are concerned. So this also the one interesting statistics that we can have. It is again taken from the government of India side, Minister of Power. Electricity generation, only conventional sources, okay, oil, gas, and coal. Electricity generation, conventional sources, year-wise. So it is taken from the government of India website. So along the y-axis, it is again the number of units generated in terawatt hours, and along the x-axis, it is nothing but the yearly duration is taken into consideration. 2009, then 10, 11, 11, 12, 12, 13, and likewise. So from 2009 to the 2019, a small gap, small period of the 10 year is taken into consideration. So at the beginning of the 2009, it was around 771 terawatt hours number of units generated from the conventional, and now it has reached to the 1250, so slightly lesser than double. Okay, 770, and we can have a double to be around 154. Okay, 154 and something 4 digit. So slightly less than double the energies are generated from the conventional sources. What does this mean? It means that Still, we depend heavily on the availability of the conventional fuels, conventional sources for the power generation, isn't it? So, continuous and steady rise in the units generated can also be seen. And you can divide it again into the two different parts from 2009 to 2014, first 5 years, from 771 to the 967. So increase around the 200 terawatt. And then from 2014 to the 2019. So in these 5 years, from 967 to the 1249. So it is nearly more than 300, or nearly equal to 300, increase of 300 terawatt hours. So the rate at which it is increasing, that is also high, maybe of the order of 4% or the 5%. Okay, so that is very interesting facts that we can have at this moment. So that's what just now we are discussing the earlier slide. The third largest energy consumer, accounting around 5.48% of the global energy consumption, with Maharashtra as the leading electricity generator among the Indian states. Yes, definitely. Maharashtra is nothing but the second populous state in the India. Then highly industrialized as compared to the other states of the India, and definitely the energy consumption or the generation is definitely being higher as compared to the other states. So due to India's economic rise, the demand for the energy has grown at a rate of 4.3%. So that was just I was saying in the earlier slide. So maybe on the order of 4% or 5%. So roughly it is 4.3% over the past 30 years. But this increase, annual increase in the demand for the energy, so that will go on increasing. From 4.3%, it may be there 4.8%, it may 6% likewise in the coming future. Isn't it? Because the energy consumption pattern that will go on increasing, so definitely the demand will go on increasing. The rate will increase. So just this fact that we also came across at the end of July 2020, the installed power generation capacity that stood around 3,71,654 megawatt, and per capita energy consumption that stood nearly equal to 900 kilowatt hours. So slight increase in the per capita energy consumption can also be observed. And what the future plan is there? The immediate. The Indian government has set an ambitious target. The Niti Aayog have set an ambitious target to add approximately 4,57,623 megawatt of installed generation capacity by the end of March 2021. At the end of the July, at the end of the July, it is 3,71,654. By the end of the March, 4,57,000. So nearly additional 80,000 megawatt is an ambitious target by the end of 2021. So 20%, 25% increase in a very small duration of time. It is very ambitious, even though practically it may not be possible. It may take some longer time to reach up to this the Mammoth total that we are having 4,57,000 megawatt. And future prediction again, 10 years down the line in the coming future, the total demand for electricity in India is expected to be 9,57,000 megawatt by the end of 2030. So at 2020, in the July 2020, what figure that we are at? 3,71,000 megawatt. And by the end of 2030, within a very small span of 10 years, the demand is likely to be expected approximately tripled from 3,71,000 to 9,50,000 megawatt, slightly less than triple. So in a very small duration, one can see what the predicted number is there for the demand of electricity. 9,50,000 megawatt. Very huge number that we can 950 terawatt. So these are again some interesting facts. 62% of the energy consumed in India is generated by the thermal power plants. Okay, the oil and gas are not here. Then. Okay. Major percentage there from the thermal power plant, 13 by the hydroelectric power plants, 2 by the nuclear, and rest being the alternative sources. So these trends are somewhat similar, which were seen, which were discussed at the global level as well. 53.7% of the India's commercial energy demand is met through the country's vast coastal reserves. So to meet with the say ever increasing demands in the next 10 years, so in the recent year, the more focus or the investment has been say made heavily there on the renewable sources of the energy such as the wind energy, wind turbines, or the wind power plants. Additionally, India has committed a massive amount of funds for the construction of the various nuclear reactors that would generate at least 30,000 megawatt, isn't it? So different nuclear power plants are expected to be get installed, or in the existing, the capacity addition is likely to take place, which may reach around 30,000 megawatt. This is somewhat old number, that is in the year 2009. 20,000 megawatt of the solar power uh, by 2020 under the National Solar Mission. So some fund which has been say diverted in the 2000 July 2009. It was planned. It was proposed that by the end of 2020, this much amount of the would be say invested so as to produce 20,000 megawatt solar power. Now, if you would have been say, reading the news properly or say regularly, I am sure that some 2 week or 3 week ago, one mega solar thermal power plant that was inaugurated by our Prime Minister Narendra Modi. So that is considered to be one of the largest solar power plant, and whose capacity, if I am not wrong, it is around 750 megawatt, isn't it? So in a very short span of 4 or 5 years, this total plant was being say installed, and it has been say put to its fullest capacity, that is 750 megawatt, isn't it? So it is one of the biggest or the largest solar power plant in the world that we can say that, isn't it? So that is what the last line which is highlighting here, to produce around 20,000 megawatt of the solar power by 2020 under the National Solar Mission. So these are some of the numbers which may appear to be say repeatedly here. Per capita consumption 900, that's fine, which is very minimal as compared to the global average. So global average is 4 times than what the energy consumption that we are having per capita, 900 for India, and for the global average it is around 3,500 kilowatt hour a year. We are facing a lot of problem, which results in the scarcity of the electricity. So what problems are, what obstacles are there, are nothing but the electricity losses during the transmission and distribution. They are extremely high, 28%. It means that about one-fourth of the power which is generated from the power station, and by the time it reaches the end consumer through its transmission and distribution, 28% is lost, isn't it? So that is a very big point of concern. These are again some interesting facts. India needs to tide over a peak power shortfall of 13% between 5 p.m. to 11 p.m. by reducing the losses due to the theft and pilferage. So the theft of the power is also a very, you can say, the undesirable phenomenon that can be seen, so which results in the power scarcity, especially there in the peak season, the peak period from 5 p.m. to the 11 p.m. So that is what uh, the statement says. Due to shortage of electricity, power cuts are common throughout the India. The load shedding that we can see, and this has adversely affected the country's economic growth. Not only the growth in the different sectors of the economy, but in the agriculture as well, in the rural level as well. So this amounts to the 1.5% of the India's entire GDP. So that is not at all a desirable number. So despite an ambitious rural electrification program, still some of the sizable amount of the Indians, they do not have the access for the electricity due to this blackout, due to this power cutoff, due to this load shedding. So that is not definitely a good sign. While around 85% of the Indian villages have an electricity line, and just 46% of the rural household have access to the electricity. So that number need to be changed at the very rapid pace, so that the standard of the living in the rural areas, that will also be elevated. These are some earlier numbers. Okay. The electricity generation, it is somewhat 7-8 years back. This has been specifically added here in the slide so that we can compare what the status was there 8 to 10 years ago and what the status that we are having right now. So to make this comparison, both the numbers are added in the two different slides. So slightly the older numbers and the current numbers. So the data that is mentioned here for the electricity generation, that is expressed in megawatt from the different reservoirs, from the different fuels, renewable as well as the non-renewable, and the contribution which are made by the different sectors, state sector, central sector, and the private sector, isn't it? So that was the role which is played by the state sector. 41% of the requirement was satisfied by the state electricity boards. Around 30% that was satisfied with the central companies, that is NTPC, NPCIL, NHPC, and so on. Private sector nearly same as that of the central sector. Then the contribution from the coal, contribution from the gas, contribution from the diesel, very less, from the nuclear, nearly 2%, hydro, 18%, and renewable energy sources, RES stands for the renewable energy sources, so nearly 12%. So these are nothing but slightly old numbers. These are what right now that we can have as of the current status that we are having. Okay, 27th of July 2020. That is again taken from the Government of India website. It is seen that the percentage of the state sector is 27.9. Okay, the contribution made by the state sector is 27.9. That is 28%. Whereas 8 years ago, the state sector was 41%. Okay, so share which is made by the state sector have reduced in the span of 8 years from 2012 to the 2020. It has reduced from 41% to around 28%. Similarly, central it was nearly equal to 30% 8 years ago, and it have brought down now the 25%. Small drop in there. Where the private sector 8 years ago it was 29%. Okay, and currently larger share is there played by the private sector. 47% of the energy requirement are satisfied, are met with the help of the private sector companies. Okay, and the absolute numbers are given here again. Okay, slightly greater than 1 lakh megawatt from the state sector, then central sector 94,000 megawatt, private sector 1 lakh, nearly equal to 1,74,000 megawatt. We can compare these absolute numbers as well as compared to 2012. State sector 86,000 megawatt, 1,03,000 megawatt. So in absolute numbers it have increased, but in the percentage it have decreased. Central sector it was 62,000 megawatt, 62,800 megawatt. It is increased to 94,000 megawatt. So again, increase there in the absolute number, but slight decrease there in the percentage. Private sector, it was 61,000 megawatt. Okay, so both were very close. Central and private sector were very close. Private sector 61,400 megawatt 8 years ago. Now it has increased to 1,73,000. So nearly 3 times the more energy is generated, or installed capacity is 3 times increase for the private sector as compared to that of the numbers which were there in 2012, and percentage as well. There is not only increase in the absolute number, but there is increase in the percentage as well. So contribution from the private sector is more now. So that is what you can say, the total installed capacity from the different uh, fuel sources. Thermal 62%. I will again compare these numbers. Thermal, it is 62%. Here it was 57%. Here it was the 57%. So there is increase. Then hydro, it was 12.3%. What was the hydro here? It is 18.65%. So percentage have increased. The capacity for the hydro here is nearly 9,000 megawatt. Here it is 45,000 megawatt. So absolute numbers have increased, but the contribution have decreased. For the nuclear, the percentage is 1.8. What was 8 years ago? For the nuclear, it was 2.27. So percentage have brought down from 2.27 to 1.8. But the installed capacity here is 8 years ago, it was 4,780 megawatt, 4780. Right now it is 6,780 megawatt. So it means that absolute numbers have increased, but the percentage might have slightly decreased. And very interesting fact is there for the renewable energy sources. Okay, obtained from Ministry of non-renewable energy sources. Percentage 23.6, and what was there in 2012? It's 12.26. Okay, so from 12.26, it have increased to 23.6%. So within a short span of 8 years, the contribution or percentage for the renewable have approximately doubled. And in absolute numbers, here it is 87,700 megawatt. In 2012, it was nearly equal to 26,000 megawatt, 25,800. So from the renewable energy sources, the installed capacity was around 26,000 megawatt in 2012, which have increased to 87,000 megawatts. So three times the installed capacity have increased for the renewable energy sources. And if we take the percentage terms, comparison is based upon the percentage terms, then it is doubled. So that is what the comments that you can make on the numbers which are available for the different power sources. Uh, this table is very exhaustive rather, but it has been obtained from the latest updates which are available from the site. It is 27th of July 2020. And very extensive information is given on this table. You need to go through these numbers, and you can make your own comments. What the things are given: installed capacity, monitored capacity, the number of million units which are targeted, then particular days program, today's program. It means that 27 July it was targeted like this one. Today's actual. So in actual, what the things were achieved. Then the generation that is expected in 2021. Okay, April 1 till date. So it was programmed, it was actually thought, it was actually decided on April 1. Actual, what the things that we achieve, and what is the deviation. So still there is a deficit which can be seen here, it's minus. So deviation. So we are lagging somewhere there in the implementation of that policy. For the different regions of the India are mentioned in the first column. Northern region, thermal nuclear hydro plant. Western region, thermal nuclear hydro plants. Southern region, similar plant. Eastern region, northeastern, and then all India. Okay, so all this taken together, 5-6 regions taken together, for the numbers at the all India level: thermal, nuclear, hydro. Then some of the energies given to the Bhutan, and renewable energy sources, 87,000. Just now we have seen in the earlier table, and this total comes out to be 3,71,000 megawatt. Monitored capacity is nothing but the 2,83,000 megawatt. So these are very interesting numbers that we can have for our comparison, for our study purpose. Okay. I think we are almost toward the end of the today's lecture. So slightly less than 5 minutes are remaining there. If you have any such question there, we'll discuss the other points in the coming session. Okay, we'll discuss these points in the next session. Whereas if you have any question as such to be asked, you can definitely put that in the chat box. If it is not possible to answer that question in the today's session due to the scarcity of the time, so I will take upon those questions at the end of the session, and I will go through that questions, and in the coming session I will try to give the answers or justify the questions that you have asked during the session. Because once I start with the PowerPoint presentation, so it may not be visible, the chat box may not be visible for me, so due to which it puts some obstacles, restriction for me to make the comments directly. So I will definitely go through the questions which are provided there at the end of the session, and we'll come back with the answers in the upcoming session. Okay. So I hope that the things which we discuss, they are not very difficult to understand. It is very general discussion based upon the numbers and the facts that we can have. We can compare parameter X with the parameter Y or parameter Z. Okay, whatever the tabular form that we are having. So it is based upon our intuition, it is based upon our understanding that what comments that you can add or what paragraph that you can write. So that's why I said at the beginning, so you are having the freedom to write down the answers in your own words, and not necessarily that you should write down the answer in this structured manner only, from this book only, these lines are given in the book, okay, this much only should be written. It is not like that. So it is a very open way or the flexible way that you are supposed to write down your answer. Is that fine? So that's all as far as the today's session is concerned from my side. So we have discussed the trends or the energy consumption patterns, the installed capacities at national level, and in the coming session, tomorrow's session, we will discuss the facts and numbers which are at the state level. Okay, so at three different levels we had the discussion. Yesterday's session it was at the global level. Today's session it is at the national level, and in the coming session, tomorrow's session, we will have the discussion there for the state level. And if the time permits, then we will definitely start with the second part of unit number 1, that is nothing but the economics of the power generation. Okay. So thank you for your kind attention for the today's lecture, and we'll stop here for the today's session. Okay. So thank you very much.